Welcome, people. I'm going to present you some practical exercises for creating sequences of events in Max MSP. For this purpose, I have a little encapsulation that plays back 4 different sounds. In this case, these are 4 different hi-hat sounds. And what I'll do is I'll create some patches that will produce numbers 1 through 4 and thereby trigger these sounds. Your playback mechanism could be anything. You could be randomizing or actually sequencing anything, so I won't go into this now. Cool, so the first thing to look at is how to create a sequence. And in order to do that, in order to play back a sequence, I mean, typically a sequence could be easily represented by a set of numbers. Take this one, for example. So I could say there is a sequence, I've created one. Now, in order to play back this sequence, we need, first of all, a clock. So typically a metro object will serve the purpose. I'll have it run at 400 milliseconds. You need to switch the metronome on if you want it to send out bangs at the specified time interval. For that we use the toggle, sends out 0s and 1s. Best thing when you do Max MSP is to always keep testing stuff as you build, so you don't get a huge patch before you figure out what you're doing. So indeed, I'm testing my metronome. I get a set of bangs. Cool, so in order to get a sequence out of this list, we use the zl.lookup object, which receives a list to the right inlet and receives numbers that represent these indices in the left. So just to test that briefly, if I send integers into the lookup, what I expect to get is these numbers back. So once I've sent this list. So just a word on this, make sure you send stuff from the message box by clicking it after you've created a connection, because in Max MSP things don't query stuff, so the lookup won't look up the list. You will have to send the list. And now that that's done, I can actually go through the elements. So the 0th element is 1, first element is 2, 3, 4, 2, 3, 2, 3, and then it holds back again. Okay, so what I then need to do is create a sequence of numbers which is incrementing from 0 to whatever that was, 7, and back again. And that I can do with a counter. So I'm gonna count up to 7. Oops, sorry, that's a message box. I need an object box counter up to 7. And again, before I do anything, I'm just gonna test what this one does. Here goes 0, 2, 3, 4, 5, 6, 7, and back again at 0. So that's looking good. Now if I connect that to the lookup, 3, 4, 2, 3, 4, and 2, 3, 2, 3, and back to 1. Okay, so that's looking good. And now if everything is right, this will play back my hi-hats. Okay, so that's fine. Next thing to look at is changing the direction. So the counter has a few parameters, few inlets available. That you can change on the fly, so you can actually change this maximum count number on the fly. You can reset to a number. You can reset to a number on next clock, so these two are resets, and then this one will change the direction. 0 is up, 1 is down. So typically if I want to change the direction as displays, I can use 2 message boxes with these numbers. One will serve for direction up, another one for direction down. What I'll do is I'll keep these message boxes here so we see what's going on. And obviously listen to this lovely hi-hat roll. So now we're going up, and now we're going down, going back up again. Not horribly exciting. Maybe if I speed it up a bit. If you change this parameter, if you at any point change any letter, any character in an object box, you've actually reloaded the object. So in this case I have to re-trigger the starting. Okay, so that's the change of direction. And then another thing would be to randomize these elements, which we could do with a zl.scramble object. So the zl dot objects are very handy for doing a lot of list operation. I advise you to go through these and watch out, because here in the tabs you actually have a few sets to go through. Quite useful. You can analyze lists and modify them in many different ways. So scramble will scramble a list. What it needs is list sent to it, and then it outputs the scrambled list. So you see the amount of elements, the actual elements are unchanged, only the order is changed. Okay, so what I can now do is scramble these elements. In fact, what I would prefer to do at this stage is get musical already. Musical, wishful thinking. But in any case, have an option to have the original list and the scrambled list, so I can appreciate the difference. And then the scrambled one. Okay, so yeah, that's already randomization. I'll just go a bit further here and create a system whereby let's say every other bar is randomized. Okay, so how do we do that? Well, what we can do is we can first of all look at the counter and see when it reaches 0, so when does the cycle start. So this is a conditional, just like larger than, smaller than type objects, and they output 0 or 1 for false and true. So this was the 1. I mean, it's a bit unfortunate the way I've created this list is that you kind of hear the start of the bar elsewhere, but never mind that. What we want then is to select 1. Okay, so from 7 zeros and a single 1, we actually desire to have a bang when number 1 occurs. Okay, so this can be my cycle reset. And then what I would like to do thus is to, with one of these bangs, I would like to trigger the original list, and with the next one I would like to trigger the scrambled list. An easy way to do this is to keep banging a toggle, because then I would get a 0 and a 1, a sequence of 0s and 1s for each incoming bang, and then I can do another select 0, 1 to get 2 bangs respectively. So this should do the trick. Let's see if that happens. Okay, well, just to make it slightly more complicated, I'm not quite happy with the musical result, thus I don't quite get a sense of the sequence being established before it randomizes. So it's normally fairly useful to establish a loop before you get a sense of it being varied, otherwise it's all one big variation. So what I'll try to achieve then is get 2 rounds of the normal sequence and then 1 round of the next one. And in order to do that, what I can do, well, actually the select was fine there, only instead of the toggle I will use another counter. So I will count up to 2, 0, 1, 2, and then I will select for number 2. In fact, I don't have to select for number 2 because this outlet serves as the non-matching outlet. So I will get 0 bank here, 1 bank here, and every other bank here. So all I want to do then is to bloody hell, have a slightly more space here. So get 2 banks for the regular order and get 1 bank for the varied. And obviously connect this. Okay, well, not horribly musical, but there you go. Those are a few techniques that you can do here. Okay, I'm gonna simplify this one back to just playing a list. Not interested in any of this. So this is the basic list playing patch, and then what I'll do is I'll play with the timing of this pattern. And I will actually try to create a timing which is again a list based thing. So what I can do thus is create a list that will represent a sequence of time intervals. So let's do 2 200s, 2 100s. Okay, so what I then wish for is this metronome to play 2 banks at a 1/5 of a second and then 2 at a 1/10 of a second. So how do I get this done? Well, obviously it's a similar thing in terms of reading a list. So I can reuse this. Obviously, instead of this list, I will use the new one. That's sent there. And then obviously the counter has to decrease to represent the amount of elements in there. Let's see if that's... I keep getting confused with the amount of things it's going to count up to, so keep checking. 0 1 2 3 0 1 2 3, so that should be fine. You can also verify that these elements are coming through. That seems good. Okay, and then I have this playback mechanism, so the last thing to make sure is that these values first of all control the metronome timing, which is this very inlet, and then the next value is queried each time this metronome goes on and banks stuff. Make this slightly neater. Okay, so let's see if that worked. Okay, that seems to work. So that's typically control of the timing, and then you can come up with everything. Obviously the size of this list in relation to the size of this list, they can be corresponding in a way that you get a clearly repeating loop. If I make this 3 size list, change that as well, then you will get a difference in size such that you get phasing. So not every loop of the sample selection will match the duration loop, but then again they all phase back in. If you want to be flexible about doing this, just a note on the side, we have the zl.len, which reports the size of this list. And let's verify that. So that's size 3. But you see I need counter 2 to play size 3 list. And if I subtract 1 from that number and then set the count maximum with this, then what I will get is the ability to change the list size and update the counter automatically. I can try and get fancy here. Let's try this one. Okay, so that's a bit of a play with sequencing different things. So both the sample selection and the timing. You can have some fun with this. And then the next thing we can look at is a sinusoidal pattern. So can we make it such that the sample selection follows an up and down trajectory of a sine wave? So let's look at that. So first thing is, how do we create a sinusoidal pattern? Well, actually we have a sine calculation function. Now with the sine function, it is worth exploring. What you get is the sine value. So at 0, you start at 0, and then it comes up as you increase the input value, and it reaches 1 at half pi. It reaches back to 0, so you started decreasing at pi, 3.14. We can verify that. Let's do 3.14, that's pi, fairly close to 0. And then 3/4 of a pi, it goes to -1. And then at 2 pi, it goes back to 0. So what we actually want then is a system that will count up to 2 pi. Okay. Now the question is, how many steps do we want it to count up to 2 pi? Well, I won't go very complex here. Let's just work with a fixed value. Let's do 10 steps. Okay, so well, actually 10 steps, 0 to 9 is 10 amount of steps. Okay, so now that we have 10 steps here, what we want is this to go from 0 to 2 pi, which is 6.28. So what I can do is I can just multiply this incoming value with 0.628, right? Because it goes to 10. Let's imagine it go to 10. It doesn't really have to reach 2 pi because the sine of 2 pi is the same as sine of 0. So let's see how this is rocking so far. So we go from 0, and I believe that's that amount of steps, although it does look quite quick. And then if we take the sine wave, sorry, the sine value of this range of numbers, 0 to 2 pi, see we go up and then we go down, back again. Okay, so I have a sinusoidal pattern there. And then the question is, how do we appropriate this in order to select our samples, which are 1 to 4. So the output here is, as you've seen, -1 to +1, and we want it to be 1 to 4. So it's a simple range conversion problem. So the input range is 2 and the output range is 4. So we have to multiply by 2. Keep the decimals there. If I multiply by 2, I can keep checking this, then I go between -2 and +2. And then in order to go from 0 to 4 instead, I can add 2. And actually, I don't have to keep the decimals here because these will become integers in the end. So here it is. The funny thing is it goes only up to 3. So I can try to hack it multiple ways. Obviously I'm not being very accurate, it's just a conceptual thing here. I can count a bit further up, which will give me higher values there. 1, 2, 3, or 2, 1. The thing is that what's happening here is I'm running through the cycle of the sine wave. So this correction didn't help me because the values didn't go higher up after this point. If I go higher up before I take the sine wave, I'm actually running further through the cycle. So after coming back to 0, I'm just running through a bit longer. So that was not a good hack. Instead, I could make a little hack here, increase that range, and there is a number 4. Although, no, I'm doing the wrong thing, obviously. 1, 2, 3. Oh, that's funny. The 0 was in there as well suddenly. So we'll hack it. If I have a 3, it goes to 0 as well, so the range is too large. Let's do 2.5. I got a 0 in there again. Hopefully, soon enough. 1, 2, 3, 4. Going back to 0. Well, I'll be tricky again. Let's push it up a bit further. I really want to get rid of the 0. Don't want to get rid of the truncation there. Okay, so how about just slightly above? I'm really guessing now. No, I've lost both 0. Oh god, might take a while. Well, anyway, it's a cyclic pattern. I won't bore you with this. Let's quickly listen to it. Okay, so in any case I have a gap because 0 doesn't respond with the sample. Let's just have a little play with this a bit faster. Okay, what does happen if I double this? Let's play around a bit. Some funny patterns there. Faster. Okay, you can ask a drummer to do that for you. Anyhow, that's a brief set of exercises for creating sequences from lists. Thanks for your attention.